bonjour mes amis. Well, you know, for anyone new here, I am not French, but you know, I'm kind of getting sick of the same old introduction. So, yeah, I guess I did that. Anyways, this one is about JSON and Aeson. And so what I've done is I've prepared some examples to kind of show how JSON works. So I actually don't need that. And yeah, it's actually a very neat language. First things first, it's deeply connected to the auto parsing library. I'm just gonna set my prompt here. Feed me. And deeply connected to the auto parsec library. It's kind of built through the auto parsec library, and Aeson is really just providing some parsers, some parsing expressions and functions, I suppose, to the auto parsec library, so that auto parsec can parse JSON. And it also does it in a very neat way. And so I'll show you guys how to parse a given Haskell record type, which has a real JSON representation. And so I have this example set up here, Aeson example, and what I've done is I've just made a ton of fields that kind of illustrate each a important piece about Aeson. And there's not that many important functions for Aeson. There is some customization which you can do, which I think I'll leave out of this video. I mean, it's really simple. If you are interested in it, it's field modifier is the one you want to look into. You can look into the actual Aeson library, and yeah. But so as you can see with my record type here, I have one field which has its own little inner record type, which is just really simple. It's just has one field name of blah with a string. And so if you guys are not familiar with Haskell record types, does this work? Let me make sure that this is actually compiling. Did I do Aeson? What was it called? Yes. Okay, so okay, yeah, this is the first thing that really actually matters here, and the first thing that we need is that we're going to bring in this tool generic, and derive generic. And so what generic is well, a full explanation I think is beyond the scope of and how it works is beyond the scope of this tutorial, but basically it is just saying it's just providing a way to relate Haskell types to their sort of generic representation, their generic real-world representation. And so a very down-to-earth example of that is our Haskell record type is, you know, very logically connected to a JSON record. And so Haskell can actually do the work of compiling or of relating, determining the relation between your types and, you know, and JSON, and it can do that very basically. It doesn't think on its own. It can only really give you or, you know, do what it's told yet again. Like and that statement will make more sense as we go through, but yeah, that's what generic is doing. And so deriving generic allows us to say instance from JSON Aeson example. Because I have this, or I want to do this, I'm going to also need one for my inner record type, because there would be no way to create from JSON instance if one of the inner types does not have one. And so that said, all of these types do have a JSON representation. So I'm going to say from JSON inner record type, and we are good. Oh, I need to import GHC dot generics. Apparently I also did that. Oh, and I need to do a deriving of generic for my inner record type, and then this should finally work. So now I have a valid instance of from JSON for Aeson example, and so you might notice that I don't need to say where here, and that's because the minimal for from JSON. If I look at this from JSON, I can see, oh, it doesn't even have a minimal pragma. I know, well, so somewhere it does say that the minimal complete definition is nothing. So there is no pragma. We just need to simply have the generic set up, and then it can derive this for us. And have this open somewhere. Yeah, and so this is how a JSON record is represented. I have a just kind of basic, couple examples here of actual JSON, and if we look at it, it is really, while its tree-based structure is a little bit complex. Oh, this is a good example. There's only, wait a minute. It seems off. These are ugly. Anyways, okay, this works. And so while I forgot, where was it going with this? I was going to say that, there's only really a couple different artifacts that are going on in here. I'm kind of laughing because my buddy's name is Kyle, and, well, no, he wouldn't be 24. 25. But, we only have a couple things. We have of course, field labels. We have strings. We have scientific numbers. We have booleans, and we have null values, as well as nested record types and arrays. So that's really all that we need to think about, and so we have that defined here. And so a value, I have a demonstration here as well. Value is just going to a value is a parser, so it parses into a value, but there is a actual, is it down here? Yes, here it is. So, and then there was, I forget where it was, but there was another type synonym called value, which is just the exact same thing as JSON, but I have actually done this up here. Oh, and I need to do this now because I did some other stuff. And so this is the parse function from the data.autoparsec library. And so I'm just going to recreate my value of JSON example. So this is coming from this file here, example2.json. and I am going to try and parse this. Value is not scope, right. I need JSON. Oh, and then, right, because I did. Okay, so the last issue that I have here is that this has to be a byte string for this parse function to work. This parse here is, I can just do this quick. This parse function here is expecting a byte string to parse. And so if you were here for the last example I talked about, then you would know that, or the last tutorial I went through about parsing, then you would know that parsing can deal with byte strings, can deal with text, and can deal with string. They're all kind of very interchangeable, and you can write this sort of same high-level APIs or functionality about these factors. And so this is now expecting it to be a byte string, but I have it as a text. So I'm going to use encode UTF-8 from the data.text.encoding module to turn this into a byte string. And then this is going to parse with, try to parse the JSON representation of this byte string here that I've created. And so we can see that this is a valid JSON that I have here, whoop-de-woo. And I have all of the different artifacts. I have a nested record, I have a number, I have an array, a string, a bool, null, and then two other fields, and which are different from this field here. And I will get to why I have that. But yeah, so now you don't actually. I wanted to use this parse function here just to demonstrate the relationship between Aeson and the autoparsec library, but how you would typically do this is there's the decode function, and so this is looking for a lazy byte string, which is really just a byte string that is lazy in its representation. And so it will not evaluate until it's demanded, which is the same for any laziness. And I will do probably some deeper explanation on laziness and just other concepts like that in Haskell. But I don't see them as being necessary for learning how to code in Haskell. Yeah, maybe in some parts, but I explain those where they come up. So, so then I guess also too, this means that I could just say decode. Oh, and there's one last thing I have to do in order to make this work. I have a regular byte string, and this needs a lazy byte string, and so I always forget what the function I need is here. Was it to strict? From strict? Byte string? Yes. So from data.bytestring. Okay, so import data.bytestring. I'm going to import it qualified because I already have so much going on in here as BS. And then I am going to say bs dot from strict. Okay. Let me figure this out. Something weird is happening. I feel like I've seen this before. Alright. I realized that I don't actually need to do that. I could just use a, instead of, messing around with the types, I don't know why that was happening. That's kind of weird, and I feel like I've seen that before. I'm probably just doing something silly. But, yeah. So I have a function, well, there's a function decode file strict. And so this is where we start to actually get into, into how the Aeson library works. And so this here gave me nothing. And I'm assuming right now that it's not because of, not because of malformed JSON, because I was able to do parse with the JSON expression, the JSON parsing expression on this same file. So, yeah. But what would make sense here and would line up with my experience is that since I have not declared what the type of this is, then it does not know what it's trying to parse into. Kind of like how with read, we have to say what the type will be. And so I have an issue here where I realize that there is no show instance for either of these. Realize that in my little break. And I suppose I have to do that. And yeah, there we go. So this worked. And what was I doing? Oh, actually, I mean to do this on this. We're going to pretend that never happened. And this worked. So, this decode file strict, I only had to say that I only had to declare what the type was. So all I'm really saying here is that it must be an Aeson example. The reason I have the IO maybe here is because if we look at the type of decode file strict, it's IO maybe A, where that A is has a from JSON instance. And so here I do have a from JSON instance, and so I can do that. Let's say I was to get rid of this. And I try doing this again. It would say no instance for from JSON Aeson example. So my type annotation would violate what the function is capable of doing. It cannot parse something that it does not have a from JSON for. And so I put this back, and everything is back to normal. And we are able to parse. So now a cool thing to note is like the difference between these two. You would have seen a second ago that I was able to parse both. I meant to parse example.json and then build the example2.json. But if you look at these record types, I mean, the first thing you might notice that's a peculiar interest is that these all have to be the same in terms of this accessor has to be the same, as the field name, and same here, right? You can see that pattern. Array, I'm not honestly sure what would happen with non-homogeneous arrays. Like, what would, I'm kind of curious to try this in a second. Yeah, so that's the first pattern. And then the second pattern that you might have noticed is these not so subtly named fields of irrelevant and also irrelevant. So if I go back to example2.json, it still parses properly, and in that proper parse, it does not have those fields of irrelevant and also irrelevant because I have not declared them. So I don't have to consume all of the JSON. I only have to kind of select what I want to keep. And yeah, that's pretty much it. And you can see too that it, of course, was successful with handling the inner record type as it should in order to be a valid JSON parser. And it would not matter what this inner record type was as long as we had a from JSON instance of it. And you can write a from JSON instance for really any type in Haskell besides functions. And so the other thing I wanted to show is, like, if we don't want to have this, kind of auto-generated case. So we have this, so I worked on a project, Nervo's Force Bridge, and for this project we had to do a lot of RPC, or remote procedure calls, and so we were dealing with a lot of JSON data, and so that's kind of actually where I learned about Aeson. So there was a case where we were working with the smart contracts of the Nervos blockchain, and definitely not going to get into the complexities of that domain, but there was the core thing that matters is there was this idea of a dep type. And so let's say we have a data type my record, having a record here, and we have dep type, and dep type is of a dep type. So in this case, we are converting from a raw string to a clear Haskell type. And so in this case, we are going to be manually define our from JSON instance. And so there's a lot of these functions like with text. So let me try and find this quick. Perfect. This is definitely a quick way to find it. And as you can see, there's a sort of family of these functions of with, and it's just the easiest kind of way to work with a particular JSON type. And so you're effectively saying that I know that the JSON type will for sure be of this type. I know will for sure be text, and so I want to I want to use this function of with text. You give it a name of dep type, and then a function for how to deal with the cases of text. And so with text is asking for a function that takes a text and returns a parser A. And so this text is what with text is going to find. With text is going to run your function and you run your supplied function on the text that it finds. And so let's say it finds a dep group, then we're going to say that it should give us back a group. And so we have pure here just so that we promote that into the monad of the parser, and same with code. So there's only two possibilities, two real possibilities of our dependency types, and we just turn them into real Haskell values like so. Otherwise, we just fail and say that this is not a valid record. Effectively, it says obviously not valid dep type here, but the whole thing would fail. And so and that would allow us to parse something like this, where the actual JSON would look like for instance. So and that's really all there is to say. Yeah, and on my GitHub, Augie G, there is that project which has a bunch of cases of how to do, Aeson type operations. If you go into the back end of the, where is it? This here. Oh, whoa, what did I do there? This is the actual file path where you can see some of the, from Aeson instances. For instance, there's another one here, and this is kind of, I was looking back at this, I'm going, why did we even need to make this by hand? I don't know. And this is just, another way to, this is effectively doing the exact same thing as what a derived from JSON would do. Well, actually, no, this is not true. Sorry, I misspeak as I read. The only reason, if let's say the record type I can tell from this is going to be testnet, and we want to call that record testnet address. And so if we want a bit of customization around it, here's where we have to be sticky about what the field names are. These have to be the actual field names, and then we can basically build our account, which will be, in this sort of ordering, a mainnet address, a testnet address, a lock arg, and then a lock hash. And that will build it with our neat new field names. But that is definitely it for talking about Aeson. And again, thank you so much for watching. Really hope these videos are helpful for you guys. As always, please let me know if there are any kind of comments, critique, feedback you guys have, or how I can make these better. Anything in particular you want to see. Yeah. So otherwise, bon voyage and happy coding.